Hello, friends. This is Eli from Mystic Circuits, and I'm doing another DIY build guide. This time we're doing fan favorite, the Blinkus. What does it do? Who even knows? But it's fantastic, and you're about to build one. So this is what you should see when you open your kit. Let's go ahead and take everything out, make sure it's all in there. So first thing you'll see are the instructions. These are the instructions for, like the real basic overview. If you've already built a bunch of kits, this should be enough to get you there. But you'll notice there's this QR code that'll send you to the Blinkus page on the GitHub, which should have your it'll have more detailed instructions that are written out into a Word document. It's possible that you came across this video through this QR code. We can go ahead and set this to the side for now. You'll also get a piece of paper with all of the passive components in it. There are two different value of resistor. You don't want to get them mixed up, so we'll be populating these one at a time. And then you should also have 4 LEDs. And another bag with all of the other components. Let's go ahead and open this up, dump it out, see what's inside. And we want to make sure that everything is in there right at the beginning, just because, stuffing these kits, sometimes a part doesn't make it into the right bag. And so it's good to just check right at the beginning that it's all in here, right? So we have our lid to the case and the bottom of the case. We have 2 short sides and 2 long sides. The long sides have the Mystic Circuits logo on it. The short sides have these 2 holes for the jacks to go through. And we have our main circuit board. This is something we're going to want to keep around. We'll have 4 jacks. You know what, I'll just lay it over here so it's easier to sort of identify everything. We have 4 jacks. We want 4 of these bolts. 4 nuts. 4 rubber feet. All right. So that should be everything. If you have everything, we can go ahead. If not, go ahead and shoot me a message. I'll make sure that you get taken care of. First, we're going to move all of these case pieces out of the way for now. We don't need to use them until later. And we are going to focus on this part with the circuit board. I'm going to go ahead and zoom in. Now, this is on the easier side for DIY kits, but I wouldn't suggest it for your first one. They're easier kits. I usually suggest people start with the attenuator just to get the hang of things. It's very hard to mess up. The Blinkus, for the most part, it's a pretty simple kit, but you're going to have to do a couple of things in the right direction. So we're going to start with that. You'll notice on our circuit board that there are these 4 sort of half, what's the right way to put that? Flattened circles. These 4 flattened circles on the inside of the board, right? And that each one has a square pin hole, a square leg. I'm losing my words right now. Basically, each one has a square hole and a circular hole. The square hole is always facing the flat side of the circle, and that is facing a different direction in each case, sort of almost making like a swastika kind of shape. And you'll see these LEDs have a short and long leg, as well as, I'm going to have to manually focus for this because it's kind of hard to see even in person, but the LED is a circular part that has a flattened edge on one of its sides. There's like this little skirt on the bottom. If you look really closely, you'll see that the side with the shorter leg is flat on the skirt. And it might be the kind of thing that's hard to see on camera. You know, I'm not amazing with the lighting, but I'm doing my best to show it here. Anyways, the point is that the flattened side of the LED with the short leg is the easiest way to identify it, right? That goes into the square hole and the flat part of the circle on your board, right? So again, flat side is on the left, short leg pointing left when I look there, right? So we're going to go ahead and push that all the way into the board so that there's no leg sticking up between, like, we don't want this. It looks bad and it can possibly get bent over. So we're going to go ahead and use our finger, push it into the board as much as possible, and then we're going to take the legs, shoot them out in different directions, all right? Now we're going to take this next one, short leg, square hole, flat circle. Let's stick it over here, all right? And if you do this wrong, you'll probably still get some kind of result out of Blinkus, but it's not going to do what it's supposed to be doing, right? Which is sort of doing ring modulator kind of things. There might be some scenarios where it turns off, whereas with the ring modulator here, it doesn't usually turn off. So yeah, I would say just try and make sure that short leg, flat side of the LED, square hole, flat side of the circuit board, all of these things match. The short leg on an LED refers to the cathode of the LED, which you might remember that word from the OR gate video if you've been watching them all in succession like I have. The cathode is basically the directional component of an LED. So again, short leg, flat side of the hole, flat side of the circle, square hole, all of these things are meant to go together, right? So now we spread these legs out. You can see that there are some holes that are going to be kind of easy to cover with solder, like accidentally. So I'm going to go ahead and kind of bend these legs in towards each other in order to reduce that likelihood. And you're not going to get it perfectly, but just generally, like, there's a lot of close components on here. You can see here that these legs are going over these larger pieces, but not on the small ones. The small ones are the ones that are really easy to accidentally get solder in. So if you have to make a choice, try to cover the large holes rather than the small ones. But now all of these seem to be mostly facing away from each other. So I'm going to go ahead and get started soldering these. It should be, I guess, an easy way to check everything before you start soldering this. I'm going to just adjust the focus really quick, is that the short legs should all be pointing like in a circle. So short leg, short leg, short leg, short leg. And if you need to double check, you could just bend these back towards each other. It's pretty easy to see. The short leg is always on the same side in a circular sort of pattern, right? So now, if you have never soldered before, again, I wouldn't advise this is your first kit, but I'm going to go ahead and show you anyways before we solder. What I meant to say is that I have a video explaining sort of soldering best practices and safety tips. It'll be linked in the description, but basically I'm going to be the best practice that I always advise is to tin your tip right before you're about to solder. It's just going to, and tinning the tip involves just wasting a tiny bit of solder. You put a bunch on over either your sponge or your solder. What would you call that? There's a word for this thing. I'm spacing on it. But basically, you make a big ball of solder. It sort of like make sure that the surface of your iron is primed for soldering. And then I'm going to go ahead and zoom back in. Usually when I'm soldering, I apologize if you've watched a bunch of these videos already and you've heard me say this, but basically a lot of people, when they first start soldering, they think they're supposed to take the tip of the iron and put it right onto the joint they're doing. That's not correct. What you actually want is you want to take the side of the iron and place it flat against the joint that you're about to heat. That increases the amount of surface area and therefore heats the joint more evenly and quickly. Right, and then you're going to place a little bit of solder in. And I also always do my best to make sure that the circuit board is oriented in such a way that I don't have to bend into an awkward position in order to... I'm just going to reflow this really quick. It didn't look like it was a good joint. In order to, like, I'm not moving my arm like this because that puts my wrist in a weird position. I'm just rotating the board so that I'm in a nice, like, natural position when I'm making these joints. You know, soldering, it's kind of like using a computer. Like, if you spend a lot of time doing it, it can, you know, make your wrist a little sad. So, and also, like, the results are going to be better if you're comfortable while you're doing it, right? No point in making things harder for yourself. It's just good to sort of move the board so that it is facing in a way that makes your life as easy as possible. Right? So this is the last joint for these LEDs. I'm going to go ahead. I can see here, it's kind of like a big ball of solder on this one. It's probably fine, but just in case, I'm going to reflow it. You can see I kind of pushed the solder up the leg so that it had somewhere to go. And now it's a lot skinnier. But yeah, overall, these joints look good. But just to verify, what you're going to want to do is to wait until the joints are cold, because they're going to stay warm for a little bit. And then you pick it up and you wiggle it around. You can see how this section of the leg isn't bending, even though I'm bending the rest of this. That indicates that it's making a nice strong joint. Like, the force of the joint itself is, why do these look like they're not soldered? It's because I didn't solder them. Okay. So actually, this is a good example, right? You'll notice that there's this ball of solder on this joint, but when I move the leg around, you can see the whole thing is moving, right? As opposed, and on here, it looks like I didn't even get any solder on at all. Whereas over here, if I move the leg, first of all, this leg is staying still. Second of all, that ball of solder that's on the circuit board also staying still. So I'm kind of glad I got an example of, I'm going to move this around. Did I forget to do this? I don't know. I must have, it's towards the end of the day, and this is like my fourth or fifth film, demo video I'm doing, so I'm losing a little bit of steam. I might have to do the rest tomorrow, but, I want to get these up, and leaving the film set up, all the lighting and stuff, like, you should see my room. It's like, it's not easy to move around in here, so I'm just making sure that these joints are good. Doesn't hurt to reflow things if something doesn't look quite right. And you can see already that looks a lot better. I can't see the holes where the solder is supposed to be anymore. If I wiggle this around, this leg is no longer moving with it, and the lower portion of the leg isn't moving either. So it looks like all of these joints are good. So now what we're going to do is we're going to take our wire cutters and we're going to go in and cut the legs as close to the circuit board as we can. Now what you want is for the legs, what you want is for the blades of the cutter to make a smooth sideways motion towards each other. What you don't want is to get a grip of the leg and then pull outwards, right? That can possibly lift the traces, cause damage to the joints that you just made on your board. If your cutters feel like they're not doing a good job, then you might consider getting sharper cutters. I've had these cutters are like $10 and I've had them for a long time. They've never gotten dull. So now what you should be looking at is 4 LEDs all on the circuit board. Back of the board will look like this. If you see any of these legs sticking out really far, go ahead and cut them a little thinner. But yeah, now we can go ahead and work towards our resistors, right? And we're just going to start at the top with the 100Ks just because that seems like a logical order to me. So now we've got 4 resistors. We're going to take the paper off the top and bottom, and I would suggest leaving the 1Ks on the paper that we just looked at just so that it's easier to keep track of them. Now, when you bend your resistor over, you're going to leave it so that one side's leg is going straight out and the other side's leg is bent all the way over 180 degrees into a little U-turn kind of shape, right? Now we're going to be looking on the board for anywhere that says 100K, right? And it's pretty easy to keep track of because the 100Ks are all closer to the top and bottom edge of the board, and the 1Ks are all closer to the middle of the board, right? And just because you can see this circuit board from the outside of the case, I like to make sure that everything looks symmetrical. It's an aesthetic thing. It doesn't really matter for the functioning of it, but we're going to go ahead and take that resistor leg with the body on it and put it through this hole that has a white circle around it. And then I'm going to take the shorter leg and put it through the other hole with the 100K next to it, right? And then same as with the LEDs, we push against the component with the board, and I'm going to go ahead and stretch out these legs in different directions to hopefully reduce the likelihood of it being attached to anywhere it's not supposed to. Next resistor, take it, bend it all the way over into a little U shape, U-turn, tiny resistor. I'm going to take the side with the long leg, put it through the white circle, short leg, put it on the other side, right? And it's easy to keep track of which holes each resistor goes through because there's a little white line connecting the 2 adjacent holes that are supposed to be connected with the resistor. So if we look at, for example, this one, right, you should be able to identify that the resistor shouldn't be going between these 2 holes or these 2 holes because none of those have a white line going between them. These are the only adjacent holes next to this 100K symbol that have a white line going through it. So we're going to go ahead and put the long leg, we're going to put the long leg through the white circle, short leg through the other circle, and I'll show this all to you again before we all solder it, just so that you're able to verify everything. I'm going to take this other resistor, U-turn the bend, long leg through this white hole, short leg through the other adjacent hole. All right, so now the top of your board should look like this with these 4 LEDs populated and these 4 in the middle unpopulated. The bottom of the board should look like this. Now, we're going to go ahead and solder again because we left the soldering iron unattended for a little bit. We're going to go ahead and tin the tip again. I'm doing that off screen to make it easier to extract the fumes. And now I'm just going to go ahead and start with the closest LED or resistor leg to me. And I'm going to be careful not to get excess solder into that hole I just touched with my soldering iron, which is the wrong way to go about that. Just try not to touch any of these other holes, these empty holes, with your soldering iron, right? So I'm kind of pushing towards the LED, or I keep making that mistake, the resistor leg right here, right? If you get a little bit of solder on there, it's not a big deal. If you have solder braid, that's the best way to get rid of it, but try not to. It'll make your life easier. I'm just going to do the same thing I did before and go in a little circle, kind of getting each resistor leg in succession, right? Again, I'm going to even move this out of the way a little bit more. Trying not to get solder anywhere it shouldn't be. And then all right, so all of those are in. I'm going to go ahead and I can see one or two joints on here that look questionable. I'm just going to go ahead and reheat. If you ever see a joint on one of your boards that you're like, I don't know about that one, just reheat it right away. No point in guessing. You might have just saved yourself a bunch of work trying to figure out what was wrong later. So I'm going to wiggle all of these in succession, and everything's looking good. I'm going to go ahead and flip them all towards the sky. All these little resistor legs are now testifying, and then we're going to go ahead and cut it off each one. Making sure to get our snippers as close to the circuit board as is comfortable. I had to move my trash can a little closer. I throw, instead of like taking a resistor and throwing it just on my mat, you know, I do my best to throw things out directly after I remove them. It just, you know, saves me the time and mental load of cleaning and having visual clutter on my work area. I'm sort of, organization is not my strong suit, so I have to put some extra effort into it, right? So there's that. That's what things should look like for you currently. You should see all of these 1K, 1, 2, 3, and 4 spots open, and you can actually see I got a little bit of solder on one of those holes. I can show you what to do about that. But now is our chance to do the 1K resistors. We're going to go ahead and take those off. And I'm going to do the 3 that don't have any solder in them. We're going to go ahead, place that in there. Again, long leg goes through the white hole. And then we're going to separate the legs. Sorry, that was all happening off camera. I'll show you again. So you turn the LED, the resistor, right? Long leg through the white hole. That goes in here. Separate the legs. We'll clean up the legs again before soldering. It looks like that's the one that has solder in it. So you might not have this problem, and you might be able to just put your resistor through this hole. But for me, I feel like this is a good opportunity to show people what you can do if you don't have any braid available, especially because this is a pretty dense build with a lot of adjacent holes. This is an easy problem to have with this build. So I have braid in a box somewhere, but I also have these solder sucker things. These are probably, I've used the Hako automated, suckers. I've used braid. I've used a bunch of different things, especially for me because I used lead-free solder, which is harder to desolder. This is probably the best thing I've ever used. So go ahead and made sure the plunger was primed. we look at we make sure that the plunger is over the hole it's supposed to be on. And then I'm going to go ahead. Sometimes it actually helps to redo the solder joint, because if it's just sitting on the edge of the hole, you might not. You might just pull the solder through the hole, and then it'll just sit on the surface on the other side. So if this doesn't work for you the first time, try reflowing the solder in the hole. And now I'm holding the plunger on one side. I'm heating up the solder on the other side. I wait until it's nice and loose, and then click. Voila, both holes are open. Now, by the way, this is really hard to do without this little soldering vise. I would advise getting one. They're not very expensive, and they make your life a lot easier sometimes. A good vise is hard to find. So I'm going to go ahead and place the resistor in the position that it's supposed to be in. I apologize for this little detour, but I figured it was important to show. Sometimes the other method that I tried that might have been edited out works. Sometimes it doesn't. So what we're going to do is we're going to go ahead and make sure that the legs are all going in a direction away from all the other solder points. I'm going to do the same thing I did earlier and tin my iron. Start with the leg that's pointing in my direction already. Just gonna go in a circle from there. Again, try not to get solder into any of the jack holes, so it'll be a bit of a pain to get them out. All right. All right. So you can see here, these holes look uncovered, even though you probably just watched me put solder next to them and, you know, move on to the next one. The solder didn't take, right? And that just happens sometimes. Especially, it's hard for me to see all the way over there right now because I have all this film equipment in the way and the angle isn't great. So I'm just going to go ahead and hit these one more time. This is why we check at every stage of the process that all of our joints are good, because sometimes you can hold your iron right there and it seems like it should be soldered, but it is not. All right, everything's looking good. I'm gonna go ahead and wiggle all of these legs. All right, I've got these snippers. Gonna take them and get rid of some of these legs. I guess I should probably get rid of all the legs, huh? Even here, it's good to just kind of shorten it. Looks like I just took a little chunk of solder from one of the other legs over there. Good to get rid of those things. Get rid of this one. This one. Get rid of this one. Okay. We're almost all the way done. All right. So this is what you should see on top. This is the bottom. So the last thing we have to solder is the jacks. And this is a design where the jack holes, for whatever reason, they're slightly too large. So we're going to have to do them in a different way than the other ones. All right. So what we're going to do is we're going to do one jack at a time. We're going to hold the jack in place. And we're going to take our solder. I'm going to zoom out a little bit. Take our solder and just stick it up in the air. Do a little bit of tip tinning. And now make sure to do this on the hole that actually has the jack in it and not one of the empty ones, because that'll make your life a lot harder. But basically we're going to take the iron, place it next to the lug, and then we're going to push it into this solder that's just sticking up in the air until we've got a nice solid joint like that, right? Just to hold everything still. Gonna go ahead and do that on the next one. All right. All right. You can see that these two are good. I'm going to move the solder closer to the middle of the screen. We're going to do another one. It's nice to have a lot more solder than you think you're going to need sticking up, just because sometimes the joint doesn't take as quickly as others. And sometimes you can also just kind of leave the blob next to your lug that you're soldering. Kind of see how it goes from there. All right, I have a sufficient blob. I'm just going to leave it next to the lug, kind of press it in. It's not fully covering the hole, but I can tell that it's making a good connection. Right, and at this step, we're going to sort of make sure all of our jacks are sticking into the board. Something that you can do just to be sure is to take the short side, stick it through the jacks, just make sure that everything seems like it's nice and aligned. And then we're going to go ahead and do the rest of these solder points. I like to do all of the lugs that are facing in one direction at the same time, and then rotate the entire board and do the other ones. This is technically a design where the sideways lugs don't do anything, but if you're at all unsure about what's supposed to happen on this board, I would suggest just soldering all of the jacks, all the jack lugs, just to be safe. But yeah, there are no normalized connections on this design. So these four that are facing sort of lengthwise, not absolutely necessary. All right, this is the last joint. There we go. So we're done soldering. Go ahead and take a look over everything. Make sure it all looks like this. Right? Seems like everything looks good. I'm going to go ahead. I can see right here there's kind of like a little wire that might accidentally bridge to something else. I'm going to get rid of that. I see another one down here. And like with the other designs, I am going to suggest that you cut these 6 jack lugs that are closest to the center of the board. So 1, 2, 3, 4, 5, 6, just in case. All right. Now we're done with that. We can move on to assembling the case. So, going to zoom out again, focus again. Oop. Now, you might be seeing the attenuator side of things. What we want is the Blinkus side, and we want the text on both the circuit board and the Blinkus to be aligned. To be honest, the Blinkus is probably the one where this matters the least, but it doesn't hurt just to make sure that everything fits nicely. Now, the best way to assemble the case is to take a look at the lid and then do the short sides first. These are the ones that the jacks go through, right? And so we have these 2 short sides. You'll notice there's a tab on top of each side that goes through this hole in the lid, right? So I'm going to use the lid as a reference. I'm going to put the short sides on each side. You can see the tabs are facing in opposite directions. It's because the tabs in the lid also face opposite directions. Now we're going to put the tabs through these holes on the top. And you can see these 2 holes are now occupied. You should see something that looks sort of like this. And now we're going to put in the long side. So I like to have my logo or my the name of my company facing up. So I'm going to go ahead and place that into that hole. Place this other side into this hole. And then you can see all 4 of the sides kind of fit together like puzzle pieces. So we can flip things over. We're going to take the bottom piece, make sure that the holes are all lined up with where the tabs are supposed to go, and press everything together. I apologize that a lot of that was out of focus. So this is what you should be looking at. The last stage of this is to take these bolts, put them through the corner. We're going to do 1 corner at a time. If you don't easily feel it slide all the way through, you can use a screwdriver to either screw through or just kind of wiggle until the holes are aligned. We put a rubber foot and a nut on that side, and then you use your finger to hold the nut into the cavity of the rubber foot. You can kind of push on the side if the screw doesn't immediately mate with the threading of the nut. Again, screw, foot, nut. Okay. All right. That should be everything. Your Blinkus should look something like this. Here's the backside with all the screws nicely set in. And yeah, I'll go ahead and attach a short video showing how to test this at the end. Otherwise, thank you for watching. Okay, we're going to go ahead and make a little video showing how to test the 0 HP Blinkus. Usually what I do is I plug an oscillator into one of any of the 4 input jacks. They are all inputs and outputs. And then I plug a second oscillator into the second one. You should start to notice all 4 LEDs going, and you can see when I plug that second one in, the LEDs turn a lot brighter. And then if you patch out of here, you should be able to hear some combination of the two. You patch out of there, another combination. I'm going to go ahead and make this oscillator go into LFO speed, and you'll see the lights slowly moving now versus faster. And yeah, there you have it, your 0 HP Blinkus. Even with no sound, it's still blinking away. So yeah, this is one of our easier and more fulfilling builds. I feel like hopefully it's working out nicely for you. And yeah, if you have any issues, let us know. Leave a comment, shoot us a message. But I hope it worked out well for you, and happy patching.